Hello, everybody. Thank you for being here. It is my pleasure to introduce Effie Perreira today. Effie Perreira has earned her PhD working in the Attention and Social Cognition Lab at McGill, where we met. Her doctoral work focused on the effects of social stimuli on selective attention. Then she moved on to her postdoctoral work at Waterloo University, where she was awarded the prestigious Bunting Postdoctoral Fellowship for her work on mind wandering and the temporal dynamics of attention. She is now the director of the Queen's Attentional Dynamics Quad Lab at Queen's University. Please welcome my dear friend and excellent scientist, Effie Perreira.
Thank you so much. And thank you for having me here for the talk. I'm really excited to be able to present some of the work and show you the kind of thought process in terms of things that I did starting way back in my PhD and then developed through my postdoc and now continuing on with my own lab. So to start and to introduce everyone to my big topic, one thing I always like doing is opening with this video. You'll see me for talks for the next 5 years. I'll still start off with this video. It's because I love being able to show people this video of someone just walking through a sidewalk in Paris, in France. And I just want you to watch and just tell me what you see. Just think about and keep in mind the things that you're actually paying attention to here. Now, some of the first things that I can probably guess about what your attention is doing is it's moving around all over the place. You're likely selecting and shifting, fluctuating on different things from here. The second thing that I can almost definitely guess is that even though there were these brightly colored umbrellas and things from that, these are the things that you are likely focusing on. And not simply because these are just the stimuli in our environment that are moving, but it's because social information, people, their faces, their eyes, represent some of the key building blocks of our entire world, our entire sociocognitive system. Numerous research across a number of different dimensions have demonstrated that people, faces, and eyes convey very critical information to us in terms of how we can understand the emotional states of others, how we judge ourselves, judge other people, how we understand something about general behavior and norms. And it's specifically, these are the key reasons why people, faces, their eyes, and social information are so important, because they represent these very, very key building blocks for us. So throughout the literature, over decades at this point in time, we always talk about the power of social attention, right? How our attentional processes prioritize people, faces, and eyes over and above anything else that you could really ever see. That without fail, if social information is around, you're attending to it. Your attentional system is going to be very, very specific and directed to it. But in the video that I showed you earlier, one of the things that is always very clear for that is that this feels very automatic, right? You're doing it. You can't help but notice people. You can't help but follow and track them as they're walking down the street. But one of the things that we find both within the literature and within my work is that even though it feels very automatic and preferential, these things are very computationally intense in terms of what we're actually doing under the hood. It feels automatic, but the reasons why we tend to attend to social information, it tends to depend so much on what these stimuli represent to us. And so today I don't want to talk to you about the power of social attention. I want to talk to you about the complexity of social attention in terms of how our attentional processes use cues that signal relevancy, that signal importance, and that it's for these reasons that we actually pay attention and prioritize people, faces, and eyes over and above all else. So I started some of this work, as I mentioned in my PhD, have really evolved and developed this throughout the years, and have shown that one of the reasons that social information is important isn't just because it's a face, it isn't just because it's social, it's because these are the things that represent the key things that are important for our attentional system, and that we get this information and prioritize that for that reason. So the three big things that I'm going to focus on in my talk today is question number one, can we strip away social attention? Question number two, can we create social attention where social attention wasn't before? And then number three, can we actually gate these measures of social attention? Right? Because if social attention is so automatic and preferential, then none of these things should be true. Right? We should be able to just have social attention regardless of everything else. But what I want to show you is the complexity of this, and that, a bit of a spoiler, we're able to do all of these in multiple different dimensions and to varying degrees. So for the first big question that we were interested in kind of looking at in terms of, can we actually strip away social attention? Across decades of research now, number of studies have shown social effects in terms of how much we attend to people's faces and eyes. It's preferential, it's spontaneous, it's sustained. A lot of this work was done very, very early with Yarbus, where he presented individuals with pictures, tracked their eyes while they looked at different types of stimuli, and looked to see, okay, where were you actually looking at in this scene? And if you look at eye tracking tracings in terms of where all of these different patterns are measured, more often than not, we're staring at people. And within faces, we're staring at eyes, we're staring at the mouths, we're staring at the things that are considered important for that. There could be different things that push this around in terms of instructions, but overall, we can't help but attend to people. You can also see this in more controlled laboratory studies, where if you just present faces in comparison to other objects, so here, a face in comparison to a telephone, and just look at the proportion of saccades, so how quickly do your eye movements move towards any of these, we find, yeah, this is very preferential. You not only look at faces a lot faster, you're distracted by faces more when you're trying to do your task, even if faces aren't really important. But one of the things that we kind of thought about during my PhD is, yeah, social attention is really great, incredibly important, very preferential, very selective from that. But there are also a number of other things within these types of stimuli that aren't really controlled for across the board, right? That our attentional system cares about independent of faces. So some of these factors could be features of the images in terms of whether we consider certain things more attractive, whether they're considered novel, whether some images are presented in context, or whether they're even relevant, right? Is it important for you to understand something about the people in the scene for you to do that task? And the interesting thing that we kind of thought about and developed within my PhD is that all of these factors right here, things like attractiveness, novelty, context, relevance, these are all things that our attentional system cares about, independent of faces. It doesn't matter if it's a face, it could be an arrow, it could be a chair. These are things that still bias our attention. But shockingly, a number of work on social attention has not controlled for these factors. In some of these cases, it's a little hard to control, right? Attractiveness can be hard to control when you're talking about a face versus a telephone. But it's still important to be able to try to understand, well, is it possible that maybe some of the work on social attention could have been driven by these factors? And that was the main big question that we were interested in answering with this, in terms of, if we start taking away some of these factors, are we still seeing these very preferential, robust effects for social attention? Now, with a colleague in Simon Fraser University, we use what's known as the dot probe task, which is a very kind of common attentional task for studying preferential attention towards different stimuli. And we paired that with eye tracking. And I want to walk you through exactly what the study looked like here. So participants would first get a fixation screen, followed by a comparison social and non-social image. So this was a face compared to any other non-social object here. They would then get the fixation, the cue would go away after a very short amount of time, and they would get a target that could appear at one of these 4 locations. I'm presenting it all 4 here because it's just a little easier to visualize that they overlap with the eyes, mouth, the top of the object, and the bottom of the object. But typically participants would only get one of these that would be randomized. And what we were really interested in seeing is, okay, what happened when we presented the cue image on the screen? We had eye trackers on individuals who were doing this, so we wanted to see, well, we presented this for 250 milliseconds. It's a short amount of time, but enough that you could make an eye movement, enough that you could saccade and look towards these regions. So are we seeing any spontaneous effects? The second the face or the non-social object showed up, did you look at these objects? And then we were also interested in looking at more sustained effects. So, okay, the face in the house showed up. What happens to the target? Right? Are you now more facilitated? Are you faster at responding to the target when it occurred at the location of the face versus the other location? Now, we had other controls in here as well in terms of varying where the location of the face, if it would be in the left or the right visual field, if it appeared inverted or upside down versus upright. And all of these were control effects to show, yep, participants are in fact doing the task. All of these effects showed up the way that we would expect. So I really want to focus on these 2 kind of breakdowns in terms of what happened spontaneously when the cue appeared versus what happens more sustained at a long time. So for the first version of the study, what we did was we wanted to take the typical normal study that you would have seen in social attention. So we had multiple different cue screens here, which allowed us to introduce novelty. They varied in terms of how attractive people found the non-social image versus the social image. All of these images were presented in context. So the person was presented in a house, the object was presented like on a table, and we made them task relevant. So we told participants at the start of this task, 80% of the time the target's going to appear at the location of the face, which meant the face was now important. You should attend to the face preferentially. And again, this is something that's, even though we use a slightly different task, this is very common to the types of characteristics that we see across social attention studies. So what we did was we looked at the proportion of saccades that were broken and moved towards, from the center of the screen, towards the location of the eyes, the location of the mouth, location of the top or the bottom of the object. So did we have any saccades that went towards these regions? So that's what you're looking at here. On the y-axis, it's proportion of saccades that were moved in these directions, and the 4 different categories that we have here in terms of the eyes, the mouth, the top, or the bottom of the object. And what we see, more often than not, you were looking at the eyes a lot more, right? You were also looking at the mouth, maybe to a lesser degree, but these are the typical effects that we would expect to find in social attention. When the face appears, you are now looking more at the face than anything else. Okay, great. Let's see what happens with the targets, right? Once a target appears, are you now faster at responding to the target location? So here you're looking at the reaction time on the y-axis and where the previous, where the cue was presented in terms of the previous location of the eyes, the mouth, or the top or the bottom of the object. So here we found anytime the target was presented the previous location of the eyes or mouth, much faster at responding to it, right? So this is all well and good. Wonderful. We can replicate the effects that we found all across previous literature that shows, yep, you spontaneously look at faces and you're now much faster at attending after the fact. So we get these spontaneous and sustained effects. What I'm going to do is just kind of push these results off to the side so that we can compare it with the future iterations that I'm going to show you now, right? Because these are now a good baseline for what these effects compare to. Now with the next version, we decided to take away relevance. So here, we didn't tell participants anything about the relevancy of the faces here. We would just present the face. The target could appear equally likely at the face or the non-social object. So let's see what happens to this pattern, the same pattern of results, just once we get rid of relevance. So here what we have, same as before, proportion of saccades on the y-axis. Here we're still seeing, people are still fixating on the eyes and mouth, maybe to a lesser degree, as you can see here, both in the effect size and the pattern of effects, but we're still finding these effects within spontaneous. And if we look at the target screen in terms of how fast were you at responding for these sustained effects, well, now here's a different story. Here, we're no longer finding, just like we did at baseline, that your reaction time to targets appearing at the eyes and mouth, all of a sudden is just not there anymore. Right, so we're seeing these spontaneous effects. People are looking at faces and eyes, but it's not lasting for long the second we take away relevancy. So it's interesting. All right, let's keep going. Let's push this a little bit further. Let's see what happens when we now take away context. And the way that we did this is we completely removed any background information. So now it was just a face and a house just kind of sitting independently on a gray screen. Looking at proportion of saccades here, what we found is that the eyes are still facilitated. You're still looking at the eyes. However, the effect for the mouth goes away. And for the target, again, still can't recover any of these effects, completely flatlining. And let's keep going. Now we're going to remove novelty here. And the way we did that is previously we had many different cue screens. Now we just had the one, right? We only presented the one there. And we had attractiveness as kind of a cue variable, in that the face that we ended up using was rated as quite high on the attractiveness scale compared to all of the other faces that we had. There's still an interesting question in terms of whether you can really equate attractiveness for any of these things. I'm more than happy to chat about that because I don't think we've even really solved it in any way. But just to show you what these patterns ended up looking like, here again, we still see it just a little bit, still there, still showing up for the eyes, but still nothing for reaction time. And then for the final version of the study, we actually used a face that was rated completely neutral and a house that was also rated completely neutral across the board compared to the other objects and faces that we had. And here, still there. The effect for the eyes is still there. It still hasn't gone away. Completely taken it away with reaction time, but it still hasn't gone away for the eyes there. Even though, again, I really do want to point out that this is a very small proportion, right? This was 0.09, so it's a very, very tiny amount in terms of the number of trials and number of saccades that are going towards the eyes. So still significant, but what that significance actually means in regards to this is something that we can also talk about. So just to look at the overall pattern of the effects in terms of what this looked like for the spontaneous effects, you can see a gradual reduction in the spontaneous effects in terms of the proportion of saccades that went towards the eyes. Everything in blue is significance, versus the only time we really found any significant effects for the sustained, for the target measures, was really only when we had relevance. And the second we took relevance away, all of a sudden everything went completely flatline. So it really kind of shows that eliminating and removing relevance seems to get rid of these sustained effects, and they never really recover at any point in time. So to answer this question of can we strip away social attention? Yeah, to a very large degree. We don't fully take it away for the overt effects, but we're at such a small, tiny percentage there. And it kind of shows that we not only have this within behavioral data, but eye tracking data. And we've done some computational work to show that these effects are significantly dropping down further and further from there. And it demonstrates that maybe the socialness that we've always thought about and ascribed to faces in the past may not have anything to do with the social nature of faces, but it's these cues that they represent to us, right? It's the things that we are naturally always drawn to within regular human everyday interactions. And that's specifically what makes these cues attractive to us. And the second we start taking them away, we can start stripping away what we see from social attention. Now, talked about question one, can we strip away social attention? So now what we want to move into is, okay, we can show that we can take it away, but can we actually put it in? Can there be something that we can start to create social attention-like effects from here? Now, what has been done in the past in terms of looking at drivers of social effects, right? What is the thing that gives social effects its magnitude, its measurement, its power from there? A lot of studies have looked at this within gaze cueing tasks to show you how powerful these effects really can be. And here they tend to present a fixation screen followed by a cue, which typically ends up being an individual that ends up looking left or looking right. And then they present a target that could appear in the same location, either on the left or on the right. And what they find is that even though we tell people the face is not going to be important for this task, it's just going to show up, you just need to respond as quickly as you can to the target that appears. If the target appears in the same location that the individual is looking at, all of a sudden you're so much better. So much better. You're faster at responding to that target. You're better at being able to discriminate it, even though the face is irrelevant. It doesn't matter what we end up doing. And it shows not only the power of social attentional effects, it shows that if we take away attractiveness, we take away context, everything else, these effects are still there, right? There's still something there. So what could end up being the reason why? A number of studies have looked at these kind of external motivations that might be driving these effects. One could be simple signaling. The very fact that the eyes end up looking in a specific direction might indicate to us, well, something important is about to appear there. It could be the importance, right? It's something's looking here. That's going to be important for us to have to pay attention to. But studies have found that, well, you could replace the face with an arrow and you still get very similar social attentional-like effects. So, well, maybe external motivations might play a part, but that's not really the full story from there. So what we and other colleagues have been looking into is maybe there's some aspect of internal motivations that come into play. Things like the fact that people and faces represent things that we can interact with. The fact that they can give us feedback and positive valuations of things. And maybe that's what's driving all of these social attentional effects. Now, it's a little bit hard when it comes to these types of studies to study these internal motivations because we can't strip away these social motivations from people, right? People are imbued with these types of factors. So one of the questions that we thought of is, okay, well, if we can't take it away, what if we actually just take a stimuli and try to imbue it with these social characteristics? We give it these internal motivations that are very akin to what we find for social motivations. So what if we take a completely neutral stimuli, right? Just a little circle right here. We try to make you seem as though that's a face. It gives you this feeling that it is this social stimuli. Can we replicate what we see for social attentional effects? All right, so we're doing social attention, taking away the social part of it and seeing whether or not we can throw that back in. So I worked with a colleague at the University of Alberta, and we came up with this interesting pre-post design that we could use to study, well, what does the effects look like before we end up imbuing something with social motivation versus after? So participants first came in across 3 parts for a baseline phase. And this was a simple target detection task. So they were presented with a circle, and it was a bi-colored circle that could be rotated in one of 4 locations. So say the yellow side could face left, right, above, below. And all participants needed to do was just detect a target that would appear. It would appear on the left, on the above, left or right at that point in time. And they just needed to press the spacebar as soon as they saw that, right? So it's how fast are you detecting the target? We then get them to engage in a motivation phase. So this was a discrimination task where they got the exact same sequence as they did before with the bi-colored circle of the cue. And then they got a target that they had to discriminate between in terms of a plus or an X. But the important thing is that we actually associated one side of this reward, one side of the circle with some positive reward. And I'll explain to you what that pattern looks like. So say we had the cue here, we would randomly associate either the yellow or the orange side with some kind of reward. So say, for example, here we associated the yellow side with what's known as positive reward according to ours. What this meant is that if the target appeared in the same spatial location, so right beside the yellow part of the target, that would be associated with positive reward. So it doesn't matter where the cue was rotated, the side next to it was associated with positive reward. What that meant is that the opposite side was associated with a negative penalty. So if participants responded correctly to the target in the positive reward side, they got +5 points. And if they got the other side negative, it was -5 points. And the 2 other locations were seen as completely neutral from there. So within the motivation phase, we had 2 different groups here. We had a social motivation groups where we told them that any kind of positive reward, any points that they won was specific for the experimenter. The experimenter was a thesis student, wonderful thesis student that we had in the lab at the time. And they were like, oh, this is going to be really important for my thesis. Like, I'm so happy that you're here. You're going to be able to win points for me at this point in the study. So, give them the full instructions, but that was really the extent in terms of what they actually understood. And then we had a points motivation group where we didn't give them any instructions. It wasn't about the thesis. It was just, you're about to win points for the study. We never did anything with those points. It was never anything that turned to money. We just said win points for the study versus winning points for the experimenter. Now, after participants completed both of these phases, the baseline and the motivation phase, they came back 24 hours later to do the exact same study that they did in baseline, in that they got the same bi-colored cues. We just looked in terms of how quickly did they detect the target. So the beauty of this is that we got to look at, well, what was their baseline and how does that compare to how they performed at the test after they had this motivation in there? Should we see any difference, right? If we tried to imbue this with some social motivation, could we actually see these effects occur? So what you're going to be looking at is 2 separate graphs here, one for the social motivation group, the other for the points motivation group. And I'm also going to show you the results in terms of the change in reaction time, right? So how did they perform for test compared to baseline so that you could see what these differences are from there. So you're looking at change in reaction time on the y-axis. And we've got the 3 different timings that we had for the cue in terms of whether the target was presented very quickly or whether it was presented after a longer period of time. And I'm going to be separating these effects based off of if a side was positively rewarded, if it was completely neutral, versus if they got a negative penalty from there. So looking at the social motivation group, especially at the very, very early timing, we didn't really find too much of a difference, right? The change in reaction times was all about the same for baseline compared to test. Same at 300. But an interesting thing happens when we actually get to these more longer sustained effects. Right? So when there's a longer period of time between the cue and the target, we actually find that participants get an attentional benefit if this was a previously positive reward, and they get a negative penalty if this was a previously negative penalty from there. And we really only see that for the social motivation group because we don't see that within the points motivation group. So if we told participants you're about to win points for the experimenter, and you met this very lovely thesis student who you were winning points for at that point in time, we actually found this interesting separation in terms of this attentional benefit. Now, okay, this is all well and good, but you're like, well, but if this really was truly social, can we link it to some social traits? Can we link it to some degree of social functioning? I'm about to tell you, I have some data on that too. Because what we had was a questionnaire, the autism spectrum quotient, that allowed us to look at aspects of social functioning along a continuum. So you're going to be looking at the same change in reaction time scores on the x-axis and the score on the autism quotient score on the bottom here. I've also negatively scored this so that low social functioning is going to be on your left-hand side and high social functioning on the right. And what we see for the social motivation group is that there was this positive correlation that we end up seeing in that if you had higher social functioning here, you had a greater attentional benefit for both the positive reward and the negative penalty. But we didn't end up seeing that for the motivation group. Here we had no significant relationship and correlation there. So this allows us to maybe tie some of the attentional benefits that we end up getting to some aspects of social functioning. Not necessarily saying definitively this is exactly what we're seeing, but giving us some indication that, yeah, maybe there is some aspect of tying this in that was kind of brought about because of social functioning from there. Now, that's not the only part of the story. This was the main part that we published, but we've since replicated this study as well. Except what we did was we wanted to not just verify our measures in terms of are participants actually keeping their eyes fixated? Is it possible that they're moving their eyes quicker in one direction versus the others? So we actually had participants do this study with both an eye tracker and an EEG system so that we could look at what was happening with the neural activity for both the baseline and the test phases here. All of the behavioral measures replicated the patterns that I just showed you. So what I want to do is specifically focus on what we actually found with the EEG measures. But if anyone's interested in the behavioral measures, I've got that as the secret slide too. Okay, so again, looking at these as two separate groups here. What we wanted to do was focus on the two motivation groups and look at time-locked waveforms for the cue onset specifically. So when the cue appeared, what were we actually seeing in terms of neural data and neural activity? Now, there's two ERP components that I want to focus on specifically. The first is going to be the QP3. And this has been related to processing of rewards such that there's a more positive going component, about 350 to 500 milliseconds in like the central parietal areas. So looking at the social motivation group, if you're looking specifically at these sites, what you're going to be looking at is baseline in gray and the test phases showing up in color. For the social motivation group and the points motivation group, we are seeing these aspects of reward processing. Right, it makes sense. We rewarded the cues in both cases, so we are seeing that there is some measure of reward processing going here, right? Whether we said it was winning points for the experimenter or winning points for the study. But the interesting thing for me is if we start looking at markers of social processing. So here I want to focus specifically on the N170, which tends to be a more negative going potential, about 170 milliseconds, kind of in the right occipital temporal area. And here's where I think the data tells a really fascinating story. So here what we get is this very, very nice N170 wave that is happening for the social motivation group, not happening for the points motivation. I really want to reiterate, we're not showing them a face here, right? All we're doing is just showing them a circle. We're showing them a circle and we're actually showing some measures of processing within these social processing areas. That's incredibly cool. We weren't really sure that we were going to end up seeing this. One of the reasons we wanted to include this is because we thought maybe there'd be modulations for the reward processing, but we were really fascinated to be able to see this N170 form up here. So in the previous behavioral measures, it showed us these attentional benefits. It showed us we can link this to social functioning. And here's some very, very nice evidence that it also links to social processing too. And again, I want to be very clear. It's a circle. We're showing them a circle here, right? We've just imbued it with a little bit of social reward, but that's all that we're showing them at this point in time. So just to summarize again, because I always love my summary slides, to have to look at what you saw for social motivation and points motivation. What we're seeing is not really these early spontaneous effects. It doesn't really show up. These are pretty much flatline across the board. It may have something to do with the types of stimuli that we use, the fact that this was only a 24-hour delay. And I think participants only went through about 400 trials in each of the motivation and baseline phases. So it's possible we might be able to get these spontaneous effects if we try to push this a little bit more. Or if we, for some reason, try to tie it to like you could win me actual grades for the thesis, but ethics might have a bit of a field day with that. But we're finding sustained effects, right? These very, very tiny sustained effects from here. And that we can, in fact, link these sustained effects to social functioning within the social motivation group. And beyond that, we can also link it to aspects of social processing in terms of what we're actually finding for the N170. So this is all very, very cool for me. And again, it's a circle. It's a circle that we're showing. So the question of, can we create social attention where social attention wasn't? I think the answer is kind of yeah, right? That what we're finding is that these things that are naturally important to us, to our own cognitive system in terms of aspects of interactivity, aspects of social feedback and positive reward and judgment or even appearance from peers, we may not have included any of that in the study, but maybe what we're actually seeing from all these social attentional effects is the downstream effects of that, right? It's that we live in the social world, and that's what's helped us build up what these social motivations are. That what we try to do is create it just a little bit within something that doesn't have social information, and we can try to get those effects back from here. Now, I've told you these really fun questions that we got to explore, right? We can take social attention, we can strip it away. We can take non-social things and create social attention within that. So this should imply that what we can do is gate social attention quite well, right? If the things that are going to be important for social attention are going to be the relevancy, the importance, what this actually means to us, we should be able to do a little bit to be able to push these things around using measures that are even secondary to that. So what I want to do for question number 3 is talk about how we can gate social attention, right? What are the ways that we can try to study this in very dynamic ways? So for studies that have kind of recently looked at modulators of social effects, and your colleague Francesca is going to be very much an expert at these types of measures, is how a lot of people do this within interactive tasks, right? And these are some of the best ways to be able to do that because of the fact that not only are we bringing in these social factors, but we're bringing in the dynamics, right? This is a part that is a huge like love of mine. How do we study these measures across time and see how these things shift and change and evolve? So studies have looked at conversational tasks where we have 2 people sit down, have a conversation, or more of a group setting, but those tend to be a lot more complicated than not. So we'll start with the 2-person setting here, right? How do we look at these within dyads? What some studies have done is also broken this down into, well, what's happening when someone's actually listening to a conversation versus they're actually being the interactive participant. They're the ones actually conversing at this point. And they found these very kind of interesting nuances in that you may find some differences between what your role is in social attention, what your role is in this social hierarchy and combination from there. So we thought of, okay, what are some of the factors of participation that we can actually look at? Well, the 2 big ones that we came up with is one, it's this evaluation of self, right? We don't have that when we're looking at a face on a screen. At that point in time, even though that's social, that's not social in terms of how we interact with our regular everyday world. If I'm having a conversation with you, that's what we're looking at, right? That there's a part of me that I know I'm being evaluated on. You can see me, you're judging me to some degree, and you're evaluating maybe who I am as a self, which we don't tend to see if you're on a simple computer task. And then another factor of participation is a projection of self, right? If I am having a conversation, whether I'm talking or listening, am I attending to you? Do you think you're attending to me, right? There are things that come into play in terms of how someone is seen and how they want others to see themselves. And these are things that are completely eliminated when we actually use computer tasks. So these were questions we were really, really interested in studying. And we were interested in studying these and started being interested in studying these about February 2020 when the pandemic hit. So we just had no place to go at that point in time. We were like, well, we need part of this to have to be a conversation task. We can do that. So we decided, okay, we left it up alone for a couple of months and we're like, look, we're all in a lockdown. What if we actually try to see if we can measure some of these in maybe a Zoom-like setting? Right? See if we can try to recreate some of these or try to even just get at the first little peeling back of the layers and understanding what's happening with these factors of participation from that. So because of my programming background, I ended up creating a Zoom-like client here. This was a platform that allowed participants to log into a system. It gave us full experimenter control in terms of what participants could see, what we could manipulate from there. And it also allowed us to be able to build in a semi-structured conversation task within this. So we had a participant log into the system and they had a 10-minute conversation with another individual. Now, The participant talked that they assumed that they were talking to another participant here, but instead we actually had them conversing with the research assistant for the project. This was also so that we could have this be a bit semi-structured, and that topics would come up at the bottom here that would give them a little bit of direction of what they were going to talk about for the next 2 minutes. So it would be hobbies, and then they talk about their hobbies for the next 2 minutes, or classes in school that they really like, given that this was an undergraduate student population. And the beauty of this is that it really gave us full experimental control in terms of what we could do, but we also recorded audio and video information so that we could do some interesting measures in terms of what we were having there. Now, for the study as well, we had two between participant conditions. Now, the first was that we had participants have their self video on. So participants could view themselves the entire time. They would take up half of the screen the whole time while they were having this conversation. And the second was participants had their self video off, right? This was something that we manipulated specifically. We're like, no, you're randomized to the condition where the participant's video was off. But the point that I want to keep in mind is that even though we had their self video off, participants knew the full time that we were recording them. They knew audio visual was going to be there as part of the study. The only thing that they didn't have was feedback about themselves. They couldn't see themselves during the task, because we wanted to see, well, if we start to look at this evaluation of self in terms of just visual evaluation, you can't see yourself. Can we actually see some interesting differences here in terms of how social attention might be gated? Now, the way that we ended up analyzing the study from here is, if you can imagine, anytime you're working with any kind of long video data that involves these dynamic things, we needed to think of ways to have to pre-process this. So with the two conditions, with self-video on and self-video off, and again, remember, we still had their video even if it was off, so we still had all the video information. We took both of these videos, took the full length of the video, and essentially downsampled it so that we were looking at like one frame every second. So for a 10-minute video, we were now looking at something like 900 to 1,000 frames at this point. And this was mainly because what we wanted to do was, we couldn't necessarily look at social attention very directly. So we wanted to look at other indirect measures in terms of, were you expressing yourself in the same way that you were, right? Are there things about your own presentation that are actually showing up in the same ways? And we wanted to make sure we were capturing these very broader movements rather than these fine-grained changes in terms of facial expressions. So we downsampled it, so we were looking at about 900 to 1,000 frames from here. What we then ended up doing was using a deep learning algorithm to see whether or not we could detect a face, right? So simply, we knew 100% of the time participants were having conversations, there was going to be a face present from there, but we used an AI algorithm to be able to say, well, okay, can you detect specific markers on the face in terms of the eyes, the corner of the mouth, and be able to then construct a facial grid based off of this that allowed us to detect, yep, a face was present this much of the time. The detection accuracy was pretty high at 99%, but a key point I want to keep in mind, the face was always present, right? This was a video that participants were 100% of the time the faces were there. So we don't have to think about this as almost a discrimination accuracy, but just a measure of precision, right? Was it able to capture faces? And more often than not, it was. Now, once we had this data in terms of whether faces were present within that, what we wanted to do was look at categorization of these very broad facial emotions from there. And I put emotions in quotations because we had to go through a lot of deep learning methods to be able to do this. And one of the problems is that AI algorithms don't really learn emotions. They look at changes in muscle movement or changes in tone based off of the baseline image. And so I always want to put emotions in quotations, but just know I'm going to broadly talk about it as emotions from here. So the categories we wanted to look at was just neutral, which was kind of standard. The change in that, which was a positive one for happiness. We had 4 negative categorizations in terms of sadness, fear, disgust, and anger, and one called surprise that could be considered neither positive or negative in terms of the valence. And just to talk about how the deep learning algorithm ended up looking at this, is that if we had a baseline neutral face here, what you would then end up looking at is, what is the change in terms of the muscle tones and specific facial points that move from a neutral to a happy, a neutral to a sad, and then continuously a neutral to a fear. This is really great because it means that it's not specifically training on on these very broad categories that we actually think of, right? It's not specific to a facial type. It's not specific to a racial category or a gender. So this ends up being better in terms of performance. And we actually did end up finding that. So we had 3 independent raters come in and score just a subset of these images to be able to compare, well, what was their rating? What was a human rating versus the deep learning method? And we found about 89% accuracy for the interclass correlation, which was decently high for what we were looking for in this case. So that's great. Okay. This was all the norming that we ended up doing in terms of the pre-processing steps from there. Now I want to tell you about what we actually found within the data. So here we're looking at this neutral category plus the 6 different categories that the AI algorithm was able to code on. And what you'll be looking at is the proportion of emotions that were expressed by the individual. Again, emotions being quotations, but if we're looking across the entire video on aggregate, did you end up presenting a neutral face during your conversation? Was it more positive? Was it more negative or anything else from there? So looking at what happens when the self video is off. Okay, we actually found the neutral face was about maybe 35-ish%, right? 35% of the time, your face was being categorized as neutral. Checks out, totally fine. What we found is that happiness was about the same, a little bit higher, maybe 37 or so, not quite 40 from there, but about the same. Now for these negative categories, they were all pretty low. And that also makes sense based off of the task that participants are doing, right? They were paired with a random stranger. They had to have a 10-minute conversation. Hopefully it's not likely that they got into very deep-seated issues that they had to chat about. Like these were hopefully very light conversations in that way. So it makes sense that these weren't necessarily too high from there. So this is what happened when your self video was off, when you couldn't see yourself as a participant. So I want to show you what we found when the self video was on. What do you think probably happened there? Do you think these would go higher, lower, stay the same?
Higher.
Higher? No change. On an aggregate level, we actually found no change. And this was surprising to us. We thought, okay, well, you can see yourself now. So at this point in time, sure, we're not looking at measures of social attention. We're looking at downstream effects from that. Maybe there should be some difference. There should be some appearance anxiety. There should be some difference in terms of how you're judging rapport with yourself versus your partner. But we actually found on an aggregate level, no change. And you can see this very clearly when I start to combine what some of these measures look like. So looking again, proportion of emotions expressed, but now you're specifically going to be looking at just positive affect and all of the negative affect combined here. And what you can see is, again, just very similar once we aggregate these categories. Self video off versus on, no real difference at an aggregate level. Which fine, surprising. We're like, well, expected something to have to be there. But I'm the temporal girl. I love dynamics. I love how things end up changing. So for me, it wasn't about the aggregate effects. It would have been nice to have to see that. I want to know what's happening over time, right? The reason we did this as a conversation task is because we get to look at this change. We get to look at the fluctuations and the variations from there. So I want to talk to you about what the temporal data ended up looking like. So if we're looking here at the proportion of emotions expressed, just like before, looking at the time on the task. So this was a 10-minute conversation task. And if you can see it from here, these gray bars here represent switches in the topic. So that's when we presented a prompt that said, talk about your life, talk about the classes you enjoy, talk about your history from there. Looking at when the self video is off, here if you're looking at negative affect, we found this didn't really change too much, right? The proportion of negative affect emotions that were experienced were pretty stable throughout the entire task, the entire conversation. Nothing really changed. If we look at positive affect, here we're actually seeing kind of changes and variations of time. All right, you start off maybe not relatively low, but there was no significant difference between these 2 points, but then it kind of switches and changes. We have some indication that maybe this might be tied to the topics, but it could also just be general dynamics of how conversation unfolds. We don't have enough control within our study to really be able to understand whether or not it's just natural dynamics, but we're excited because we're still collecting data on this. But I love being able to see these little fluctuations and changes from there. It's very, very interesting and something that we couldn't see at an aggregate level. So now let's see what happened when the self video was on. So here for negative affect, it's still kind of flatlining, right? Drops a little here, but nothing, only numerical, nothing to really talk about, still pretty much flatlining. But a very interesting happens when the self video is on. Here, the amount of the proportion of positive emotions expressed doesn't really change, but there is this little significant drop that happens right about here, about halfway through the conversation. The interesting thing is it's not tied to a topic, right? We've done all kinds of interesting analyses to see, well, why do we actually see this kind of muted response in terms of whether your emotions are categorized as being happy or positive? And we don't really have a very clear answer for that. It's one of the reasons I was really excited to be able to present this to a very diverse group, to be like, I would love some ideas or thoughts in terms of why we're actually seeing this. We have some thoughts that maybe this has to do with the rapport that individuals experience. In terms of a conversation isn't just about one person. It's not just about, well, how do I feel? But do we actually feel like we're kind of connecting, that we're clicking? Does the conversation feel easy? So we're looking into some linguistic analysis to be able to try to understand, well, what was talked about at that point in time? Was there a depth of conversation? Was there a breadth in terms of the topics covered? Because it doesn't seem to be anything that's timed to the topic itself. So we wonder if it might be something about the dynamics of the dyad that's actually showing up here. But these are the interesting results. Again, very much still in prep. We've got the first round of data collection done, which showed us these interesting patterns. But what we want to do is try to replicate these effects to be able to make sure that we're actually getting that with better measures of appearance anxiety and other things there. But I'd love your thoughts. I'd love your thoughts in terms of what we're seeing. So overall, what we're finding, again, question 3 still kind of hot off the press, is can we gauge social attention and the downstream effects that we end up seeing for that? Yeah, we definitely can. We've known this in previous literature, but we haven't necessarily studied this across what happens through the dynamics of a conversation, what happens over time and as these things evolve. So this is it's incredibly great as a way to be able to kind of cap off the complexity of social attention, that there are multiple different ways that this ends up kind of pulling and separating out from there. So as kind of this wrap up and kind of ending where we begin, right? It's talking about the complexity of social attention. It's not simply that our attentional processes just loves people and faces and eyes over time and over and above everything else. It's that people and eyes and faces over time, what they do is they signal things that are important to us. And these signals can be turned on, they can be turned off, they can be ramped up, right? And that's the thing that's going to be most important for us to have to study moving forward in social attention. Because it's not just this understanding that faces are important, but why are they important? Like really getting at the heart of that question, I think is going to be really cool. And one of the reasons why some of the interactivity stuff appeals so much to me is that social attention has been studied very independently across everything else. But you can't take the social out of social attention, right? You have to have agency. You have to have interactivity. And anytime I see work that kind of goes in these fields, it just makes me sing. I'm so happy that we now have the tech tools to be able to develop that. And these intricate links, I think, are also what's going to be really key to understanding how and when social information ends up benefiting us in the short term, how it contributes to these long-term effects that we also see across the board, and also these very long downstream effects that we see across clinical and social populations within the different areas. And that brings me to the end of my talk. So I want to, again, acknowledge everyone that I've worked with, members in my lab, and also both at McGill and Uniwater. Thank you very much for your attention. I appreciate your time.